Okay, guys, so today we are going to do two sections. We're going to do section 8.2 and 8.3. So we're going to prove triangles are similar. It's very much like when we did congruent triangles where we had side, 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 angle, side, except this time there's only three, okay? So the only three we're going to have to worry about today are going to be angle, angle, side, 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 and side, angle, side. And they are going to be very much like the ones that we did, okay? So let me get this going here. All right, so we have the pen. We want to write skinny. Okay, so angle, angle. So in other words, if two pairs of angles are congruent, then the third pair should also be congruent. And I'm going to use the symbol, okay? Symbols are faster. All right, and it's going to look like this, okay? If these two angles are equal, then these two angles are equal. Then these third angles will also be equal because there's only 180 degrees inside each triangle, no matter what. Side, side, side. All three sides must be proportional. Okay, all three sides must be proportional. So that means when you compare them to each other, they should all be the same proportion. And I will show you what that looks like. Side angle side is exactly what it looks like. The angle must be congruent and included in the sides. Okay, so if this side is proportional to this side, and this side is proportional to this side, and this angle is the one that's congruent, then it's going to be side angle side. Okay, so it's all about the markings, just like before. They have to match. All right, so let's look at determine whether the triangles are similar. So we're going to figure out if it's angle, angle, side, 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 or side, angle, side. And then we're going to write a similarity statement. A similarity statement is a statement that you make. We're just going to write it. Okay. So first of all, I see that this angle is 90 and this angle is also 90. So far we have an angle and an angle. Now, if this one is 15, then I need to figure out what this one is. So remember, there's 180 degrees in this triangle. So there's 180. I know that angle is 90, and I know that one is 15, leaving me with a 75-degree angle. So this angle is 75, which matches this one. So that means this one up here is also going to be 15. So that means, yes, these two triangles are definitely similar because they have two same angles, at least two. They actually have all three. Now the similarity statement, that's your 1, 2, 3, 1, 2, 3. Which two triangles? So I'm going to start here. This is 1, 2, 3. So my 90-degree angle was my 1, so I'm going to make my 90-degree angle my 1. My 15 was my 2, and my 75 is my 3. So I would say triangle ABC is similar to triangle EFD. So you want to make sure that you go in the 1, 2, 3, 1, 2, 3 order, and you keep it consistent. All right, number 2, are these two similar? So I know that this is 116 and this is 30. So 116 plus 30 is 146. 180 minus 146 is 34. So that makes this angle here 34. These two up here, this is 30 plus 44. So that's 74. And 180 minus 74 is 106. So this angle is 106. So what I see when I look at these two triangles is there's one angle that's congruent. This one is congruent to this. But 116 and 106 not equal. 34 and 44 not equal. So no, these are not similar. Since they're not similar, there's no statement to be made, and there's no theorem that will apply. So all angles are not the same. So make sure you make yourself a note here. All, well, I said to move it over here. All angles are not the same. All right, number 3. Are these two similar? Now this time we're going to check to see the sides. So what I need to figure out first is the 1, the 2, and the 3. Okay, so as I look at this, actually the way you're going to do it is the small goes with the small. So look for the small number goes with the small number. And then the medium number will go with the medium number. And the large number will pair with the large number. That is how you will have to set it up. You have to check all 3. So as I look at this, I see that 1 is the smallest, and I'll look over here, and 2.5 is the smallest. So I'm just going to check. This is my new, this one is my old, and I always kind of figure the second picture, since it comes second, that's going to be new. So this is going to be 2.5 over 1. So I'm going to put this in the calculator. 2.5 divided by 1, math enter, enter, will get me a 5 over 2 ratio. Okay, so that's going to be the scale factor. So the other sides have to have the same scale factor. All right, so now 12 divided by 5. 12 divided by 5 is 2.4. So this is 2.4. So that means 2.4 is the biggest number. So it's going to pair with 6. So 6 is going to pair with 12.5 because big goes with big. So new is 6 over 12 over 5. So in my calculator, I'm going to do 6 divided by parentheses 12 over 5, math, enter, enter, and that will get me a reduction of 5 over 2 also. So far, these two sides are proportional. The last one I'm going to check is new, 5, over old, which is 2, and lo and behold, all 3 sides have the same scale factor. So yes, they are similar by side, side, side. The similarity statement, triangle what is going to be similar to triangle what. So I'm going to look at the R, go down the long side to S, to T, which is the end of the large side, or the medium side, sorry. So starting here, I'm going to go A along the big side to the big angle. So I'm going to go RST. So triangle RST is similar to ABC. So you have to stay consistent. Okay, you have to stay consistent. Let's see, did I run this big side along this side? Okay, making sure that I got it in the right order. R along the large side, A along the large side. All right, making sure, because otherwise this statement is invalid if it's in the wrong order. All right, number 4. All right, so number 4 says to show that the two triangles are similar. So to show, so first of all, do you see two triangles here? So you've got this large triangle, ACE, the big one. And then you got the smaller one, which is DBC. And these lines are parallel. Well, since these lines are parallel, that means that this angle is congruent to this angle because they're corresponding, okay? So you've got your corresponding angles because of the parallel lines. So those are corresponding, okay? Now they both triangles, the big one and the little one, they both use angle C. So this is reflexive. Reflexive. So now I know that these two triangles are similar by angle similarity statement, okay? So we're just giving a reason. We don't have to state which ones are similar, okay? But if I were going to, then I would say triangle EAC is similar to triangle DBC. So EAC, DBC. Now over here, we have a lot of parallel lines, which is good Parallel lines mean congruent angles. So I know since this is parallel to this angle is congruent to this angle. And I know that since this side is parallel to this angle is congruent to this angle. So by angle-angle similarity, these two triangles are also congruent. But to be even more specific, because you got your alternate interior angles here, so alternate interior angles. All right, so we have the alternate interior angles here, but even more specifically, they share a common side here. So these two are actually congruent. They're not just similar, but they are by angle going to be similar. Okay, and then this last one down here, we know that we have vertical angles. So this angle right here is equal to this angle here because they're vertical. So vertical angles. And then since this side right here is parallel to this side right here, this angle is going to be equal to this one because this is a transversal. So then that makes these your alternate interior angles again. So remember, I told y'all you're going to see this stuff over and over and over. So these two are also similar by the angle-angle similarity. So if you can prove two angles are congruent, then you can prove two triangles are similar. All right, let's look at the last part. It says to determine if it is possible for triangle HJK, so I'm just going to draw triangle HJK and triangle PQR. So they want me to prove that they are similar and draw a picture and explain your reasoning. So if angle H is 100, angle K is 46, so that's going to be 146. So 180 minus 146. So that's going to make this angle right here 34, because remember they have to add up to 180. Angle P is 44, and angle Q is 46. So if I add 44 plus 46, I get 90. So that makes this angle here 90, because remember they all have to add up to 180. So determine if it is possible. Well, it's clearly not possible because they don't have, but this angle is equal to this one. No other angles match. So not possible. There are no congruent. There is only one congruent angle. We have to have at least two. Okay. All right. Last one says find the value of x that makes these two triangles congruent. It may be a little hard to read on your paper, so I tried to type it over so that you can actually see what it says. So I know that RST is my 1, 2, 3. HGK, so that's my 1, 2, 3. So what I'm going to do is I know that this 2, 3, so 2, 3 goes with 2, 3, and I know that 1, 2 goes with 1, 2, and I know that 1, 3 goes with 1, 3. So I'm going to solve for x without using this fraction, okay? So set it up as a proportion. So if you want to do, this is your new and this is your old, all right? So I know that new x plus 7 goes with old, which is 3, and new, which is 8, goes with old, which is 3 minus x. Now, if we solve it this way, you're going to have a x squared in the problem, which means you're going to have to factor. Or if you want to use the fraction, we can use the fraction, and then that way we won't have to factor. Okay, So let's go ahead and save this one for later. And let's do these two. So 20 over 3 over 5. So new over old. And then new over old. Okay. So if we cross multiply, we get 5 times x plus 7 equals, cross multiply this way, 3 times 20 over 3. So now distribute 5x plus 35 equals, these 3's are going to cancel out, 20. So subtract your 35. So we get 5x equals negative 15. Divide both sides by 5. X is negative 3. Oops. All right, x is negative 3. So now, if we plugged it in, so if x was negative 3, so negative 3 plus 7, this side would be 4. And 3 minus negative 3 would be 3 plus 3, which makes this side 6. So if they had asked me to find it, that's what I would need to do. So we're able to get it a little quicker using the fraction, even though you may not have wanted to, because if you use these two, you would have had to do factoring, which we will do later. So that is going to be all of the notes for this section, and I will see you guys later. Bye.